All right. Let's start with fine tuning. I mean, we have started discussing fine tuning a couple of weeks back,
Mm,
but then we delved into the deeper concepts of deep neural networks.
mm,
Today, Pawan and others are not there, so we'll let them only take it forward with the
mm.
depths of those deep neural networks, and we can discuss about fine tuning,
Sure.
which I have some idea about. Okay,
Mm,
so. Just to recall, there are different ways by which we can improve upon the model's model's performance. Okay, the outputs that we get from the model, we can improve by two different ways broadly. Okay, first is your inference, and second is your training. Now, what comes under inference is the techniques like multi-shot prompting, right? And do you know about multi-shot prompting, Arun?
no, not much, Vinal.
Okay. Yeah, let me explain that. So it's like when you tell the model how to respond by giving it examples of questions and answers, right?
Mm,
Suppose you give a model one sample. Okay, if you're asked question like this, you have to answer like that.
mm,
Okay. Then you add that thing in the prompt only with your main query. So when you ask the question along with that sample question answer sample in the query, the
mm,
model knows by your content by your prompt, okay, that I have to respond in a particular way, the way you have answered you mentioned the sample answer. So it
mm.
responds in that way, right? So if you give one example along with your query to tell model to give answer in a particular format, okay, it is one shot prompting. And if you add multiple examples, that is multi-shot prompting. That's
Okay.
what it is, nothing more
Okay.
than that. Right. So first thing of inference by which you can get the best results from a model in a way that you want is by multi-shot prompting in the inference type.
Mm,
Second is you use something called as RAG, right?
mm,
Retrieval augmented generation, which just adds more context to your query, and then you can get better results on your query, right?
mm,
Uh, so, um, just to put it in a bird eye view, it's like this, right? So when you suppose you designed a policy, you have a policy co-pilot,
mm,
okay, and in that, whenever you make a query about, say, I need to know about the work from home policy on the internet charges for my reimbursement, okay,
mm,
then what you do is you make that query. Your query is converted into embeddings or something called as vectors also. Okay, and these vectors are queried then on in your vector database to find similar vectors, and
mm.
that whole data corresponding to those similar vectors is returned and added to your query to give more context to your query to get better results, right? So that is your another inference way to improve upon the results that you get using the inference, that is RAG.
Mm,
Okay. Third thing is uh, using your agents, right? Like MCP and all, right? So
mm,
these also help you to get more help. The whole point is in inference is whenever you query the model to get some answer,
mm.
okay, and you wanted to give good results and you wanted to give results in a particular format in the inference time, then you keep on giving examples or keep on adding more and more context to your query so that model knows exactly which space are you coming from and what do you expect in the answer, okay,
Mm.
so that it can give you the right answer.
Okay.
These are different inference ways of improving the model's results and the model's performance the way you want it.
Okay.
Second category is your training, and under training comes the fine tuning part. Okay, so what do you do in fine tuning is you actually during training only you train the model on the data on that kind of data which helps you to achieve a specific objective. Okay,
Mm,
so what you do is you take a base model, okay, and then you train it on your business specific objective data.
mm.
Okay. And then your model learns to respond in the queries corresponding to your business objective and it does what you want to do. That is
Mm.
your fine tuning,
Okay.
right? So you're building upon some foundation, and then you're nudging it to give into the particular business objective so that it can give you good results for that business objective. That is your training part. That is,
Okay.
okay. That is your fine tuning part. Yes. Okay. Cool. Uh, so any
So you have
questions for me?
anything examples or something like like how it was
Yeah.
like?
Yeah. Okay. So the example that I can think of currently is, for example, okay. Let's take an example of policy copilot only, which you implemented using RAG, right?
Mhm.
So in that example only now, uh, suppose suppose your company's CEO is some Italian guy,
Mhm.
okay, and he has his own way of responding to the queries, okay, in a
Mhm.
fancy way,
Okay.
okay, in his Italian way of saying
Mhm.
things, okay.
Mhm.
He speaks Italian English, okay, and
Okay.
he uses all those Italian and English mixed words, okay, and all that.
Okay.
Now that is like, you can, using RAG, you can pull out the relevant policy detail to respond to the user query. That is fine, okay. But
Mhm.
if you want the model to respond in an Italian accent way,
Uh,
when the model responds to it,
mhm.
okay. So what you do is you fine tune the model then to behave in that way, the way your CEO responds,
Okay.
in the way your Italian CEO responds, okay. So,
Mhm.
or maybe you make it sound like a pirate, okay, or
Mhm.
maybe something like the you. I don't know how to speak Italian, but but if your CEO is Australian, or you want the model to respond in Australian way, it'll say, yeah, hey mate, this is the policy you're getting, or stuff like that. Okay, so
Mhm.
that kind of change in behavior of the model, the way it responds. Okay,
Okay.
those things can be implemented with the fine tuning and not with RAG.
Okay. 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 Because
Okay,
RAG, I think, will give generic one. I think fine tuning, to be specific needs. I think we can modify the like output, right? I mean.
exactly. Exactly. Now, you cannot fine tune your model on the policy documents. Okay, why?
Mhm.
Because the policy documents are ever evolving piece of documents, okay.
Mhm.
They
Mhm.
keep on update every year. Your insurance coverage suppose changes, your different insurance guidelines changes, okay. Your
Mhm.
work from home internet reimbursement goes from say 1.8K to say 2.2K. So if you fine tune a model for 1 year and you use that to respond to users queries, and next year your policy documents change, even like minor changes here and there of the amount from a 1.8K reimbursement to 2.2K, or from coverage of 8 lakh of insurance to say 8.5 lakhs or whatnot, your model
Mhm.
will give wrong results to the users, right? So you have to fine tune it again to kind of converge on the near latest updates of the results, and it is going to be very expensive shit. Okay,
Mhm.
if you do that way.
Mhm.
So what you need to do is, for all those things which are very dynamic in nature, like in policy documents, okay, you use RAG to pull out the latest information,
Okay.
okay, and for the things like where you need to change the behaviors of the model, okay,
Mhm.
right? And where the behavior is static, for example, like for example, yeah, in the sense, your CEO is Italian and it responds in Italian way only, so you're making a model respond in the Italian way, okay.
Okay.
And now what you do in fine tuning is you pull the data about that person or about that CEO from different sources, like you pull out his emails, the way he responds, you pull out the different conference videos he had, different meetings videos you have,
Mhm.
different blog posts he has published. Okay, you pull all that data, you fine tune your model on all that data, then you
Mhm.
know how the model responds, then you make the model respond in the way he responds. Okay.
Okay, basically it's a no need to do. I mean, the learning the model, creating the model again, based on the specific, I mean, user or something. We have a generic, I mean, stuff for that particular user, and we just remodel. I mean, whenever we are getting the query, right, we will use those models to like generate the data, right? I mean, results.
Yeah, right,
So
yes.
it will be dynamic basically, like so the policy will be dynamic from the RAG, and whatever the modification needs to do on the data will be also like it will be a dynamic. It will be a model where it will be like combination of two models basically, right? Like I mean,
It will be a single model only.
uh,
So during RAG, you don't change anything in the model. The model
mm,
is the black box for you in that case, and
okay,
you don't change anything in the black box during the inference time. See,
okay,
inference is all about it's all about when you have already. It's like you go and buy a car, okay.
Mm,
You cannot change the core things of the car.
mm,
Okay, you can only add decorations around the car, maybe change the paint or something. We cannot change the engine, you cannot change the whole gearbox and all that. It will not make sense if you go and buy a new car. Okay. It's like buying a new car and then adding some fancy things on top of it to for it to look good, okay.
mm.
That is your inference kind of thing, okay. But
Okay.
training is like when the car is getting manufactured, okay, and it has built some basic stuff. You kind of add some more, like make it like five to six gears, change
Mm,
the engine inherently only to make be a little from 1.2 to 1.5 engine,
mm,
cc engine, something like that. Okay, so you change some core things of the car, then that is like training, and that is like fine tuning stuff. And if you change just the appearance of the way the car looks and all, that is just your inference. Okay, this may
okay.
not be the best example though, but the whole point is during inference, you do not touch the model's core things. Okay, it is just a black box for you, and you do not touch the black box. You're only worried about input and output from the box. Okay,
Okay.
and
Okay.
how you can change the output from the box by kind of modifying your inputs, the way you feed the data in the input. Okay,
Mm,
how you can get different types of outputs using the same queries like
mm,
that. That is inference. Okay,
okay.
so yeah, that is about that. So yeah, if you have dynamic stuff which keeps on changing every few months or every year or something, then fine
Mm,
tuning is a very expensive thing to do. And you better go for things like RAG. Okay, so you can always pull the latest data dynamically from your system.
mm,
Okay, and if you have some static things which you need to have your model have, like the way you respond.
mm,
Okay, you create your own digital avatar. Okay, and
mm,
you want it to respond your way, the way you respond, right? The way
mm,
you speak, the way you write mails, and also you to find your model on your data will
mm.
behaves like you. Okay, that is the way you behave, the way you speak is always the same, right? You
Mm.
cannot change every year or so, right? Obviously, unless you move to different countries, okay.
Yeah.
But yeah, I mean, the whole point is you fine tune a model on your data to behave it like, right? So it is like that. So the
Okay.
data will not, which will not change much. You fine tune your model on that kind of data.
Okay.
That
Okay.
is the whole point.
Mm.
Yeah, but do you know about RAG side of things? Like how RAG is implemented? What is the use case for RAG?
Oh yeah, I know the basics of that. Okay, like why it is used, the RAG is used. Those things I think we covered
Right.
also in the thing in the previous sessions.
Oh yeah, okay, correct. We covered, I think. So yeah, so documents keep on updating. You pull the latest documents, you vectorize them, store in your vector DB, and that's it. You're sorted. It
Correct.
hardly takes time.
Mm.
But if you have your model to be fine tuned to new data again, it is going to be expensive.
Mm.
So yeah, that are the basic. So these are two broad categories of inference and training where we can improve the model's output. We can improve the way it responds. Okay,
Mm.
that is what it is. Now,
S-
talking about fine tuning. Okay,
mm.
I do not have. I have made some notes earlier
Mm.
to talk about fine tuning, but I'm traveling now. I don't have access to my notes as well. Let's see how much I can recall. Okay,
Okay. Okay.
so fine tuning. So fine tuning has kind of four steps. Okay, which it does to fine tune a model on the new data. Okay,
Mm.
so those four steps. I'm sorry, I don't have anything to share
Mm.
on the
No, no
screen,
issues, no
but
issues. Yeah.
so first thing is the forward pass. I'll just give you the names first. Okay, first is the forward pass. Then comes the loss optimization. Then comes the backward pass or back propagation. And the fourth one is the optimization. These are the
Mm.
four steps. Okay, they will not change. Okay. Talking about the forward pass now, I think we spoke about it in a couple of meetings before.
Mm.
So forward pass is when you okay. So before you fine tune the model, your first requirement is you gather the data.
Mm.
Okay, data is the thing that powers the whole AI world, and
Mm.
data is the thing which kind of powers your training and fine tuning and your model, the way your model behaves, right? So
Okay.
you gather your data, right?
Mm.
And there are multiple ways you can gather your data. Okay, so
Mm.
first is like you are a company which has its own proprietary data like Oracle, right? So you have your data already which is available to you, and you will use that data for fine tuning the model. Okay,
Mm. Mm.
one is that source. Second source can be something like Kaggle. Kaggle is a website which has a lot of data which you can pick up for training. Okay, and
Mm.
similarly, third is Hugging Face data sets.
Yeah.
That is also one community which you might be already aware of, yes, where you can go and pull some training data set and use that for your fine tuning. Okay, then you can create your own synthetic data. Okay, you can use a big model to generate uh, your own synthetic data
Mm.
and fine tune a model on that. It can
Okay.
be something like it can be from fifth is like something from companies, okay, like Scala, like Scale.com. Sorry, Scale.com is a company which actually kind of generate data as per your business needs, and it
Mm.
can provide you with that data. Okay,
Mm.
and you can use that data for your
Mm.
fine tuning. Okay, so that is that. Now, once you have sourced your data, once you have gathered your data, what you need to do is you need to segregate your data into three pools. Okay, always three pools. Okay,
Mm.
that is your training data, then your validation data, and then your test data.
Okay.
Okay, like I would have explained before is like you have suppose uh, uh, 22K, for example, you have data training examples in your the whole training data.
Mm.
Okay, so what you do is you pick up 20K training examples, put it into one set and call it training data.
Mm.
Then 1K you put into validation, 1K you put into test data set. Okay, so
Okay.
you have segregated your data into three pools,
Mm.
right? Now, you pick up your training data and you have to fine tune a model on that.
Mm.
Okay. And why do you need validation tests separately is so you fine tune your model, then you run validations on it and to on it and capture a baseline. Then
Mm.
again fine tune it a bit more and then again capture validations. Okay. So you keep on checking the validations to see if the model is performance is improving or not improving.
Mm.
Okay. Now and with every iteration, you keep on capturing the checkpoints for the model, okay? The
Mm.
variants of the model after each training iteration to see to so that if your model kind of performance degrades after the next iteration, suppose the fifth iteration, then
Mm.
you have a checkpoint after the fourth iteration, which is the best you have gotten till now, which you can use to test the model against the test data. Okay, so
Okay.
validations help you to kind of see how your performance is improving or degrading
Mm.
after multiple iterations of training data.
Mm.
And at the end, once you have gotten your final version of model, which is good, which is the
Mm.
best you can have, which is having the minimal loss, you run a test data on that to see how it behaves.
Mm.
Okay, so that's why you have like three sets of data. Now coming to the first step of fine tuning called as the forward pass. Okay, what do you do in that? You uh, train your model on the training data. What you do is you input the queries to it, okay, of your training data, and then you already have the output with you because you have both the inputs and outputs in your data, right? Whatever output is generated by the model, okay, you pick it up and you compare it with your actual ground truth data. The technical word for the data which you have in the as the output is the ground truth. Okay, is the ground truth.
Mm.
1 second, I'm sorry. Sorry, there are a lot of kids around. Okay. Yeah, now I'm fine. Yes. So, in forward pass, suppose you have the training example, you input your query to the model and you get an output. Okay. That is your prediction from the model as per your query, right?
Okay.
And then the second thing is you already have the output of the input that you gave because you will
Mm.
have both the samples, inputs and outputs, right?
Mm.
That output that you have, which is the actual output that you expect, is your ground truth. It is called as technically ground truth is the word.
Mm.
Okay,
Mm.
and the output that model gives you it is called as prediction,
Okay.
right? So in forward pass, you keep on inputting the queries and you'll keep on getting the outputs, predictions from the model for your training data set, and you
Mm.
store those things.
Okay.
Okay, that is the forward pass. You
Mm.
capture those things, the predictions from the model. Now comes the loss calculation. Okay, second step of fine tuning,
Mm.
where what you do is you do the as the name suggests loss calculation. You see the difference between the prediction and the ground truth. Suppose
Mm.
you wanted to predict the price of a particular item on Amazon. Okay, that is
Mm.
what you're training your model on. Okay, and suppose the ground truth for that particular item is say $89. Okay,
Mm.
but your model predicted say $99. Okay,
Mm.
so $10 is your absolute price difference between these two things. That is your loss. Okay,
Mm.
right? That is your loss calculation.
Okay.
Now I'm telling from first layer of depth, okay, then I'll go to deeper layers, how it actually is in the
Mm.
loss calculation.
Okay.
So that is your loss calculation. So you
Mm.
found out that the $10 is the difference which I saw in the prediction and the ground truth. That is
Mm.
your loss calculation. Now third step is the backward pass or back propagation. What is that is what you do in that is now as you saw that there is a $10 deviation, $10 loss with your prediction, right?
Mm.
Then in backward pass step, you try to figure out which all parameters you need to tweak how much in which direction so that the loss becomes less.
Okay.
If I'm going too fast, okay, Arun, then please
No, no,
slow.
nothing. You're not going too fast. Yeah, it's fine actually. Yeah.
Okay, all right, cool. So in backward pass, you figure out how much of your parameter, which parameters need to be tweaked, how much in which direction, so that the loss becomes minimal. So that
Okay.
calculation is what you do in your backward pass step.
Mm.
Okay, and in optimization, you implement that backward pass in the sense.
Okay.
So you actually go and tweak those parameters by certain amounts in certain directions so that your loss becomes less.
Mm.
Okay, then comes the next training data, and then you check, okay, if you're, and then you run the validation again and see if your next training data, if your loss has come down or not.
Mm.
Okay, then you keep on calibrating your model towards predicting towards making the predictions where the loss becomes less and less and less. Okay, to achieve the point where we have the minimal loss, and the loss will keep on increasing after a certain point. Okay,
Okay.
it'll keep coming down, then it'll start increasing again. Okay, so you have to pick that lowest point in your uh, loss graph. Okay, and
Mm.
use that to pick up your model from that checkpoint and use that to test. That is how it is. So that
Okay.
is your four steps from a basic idea about what those four steps are and what they actually do.
Mm.
Now let's try to take a step deeper into these steps. Okay. Now first is the forward pass, right? Now let's go deeper into that. In forward pass, your model doesn't actually make only one prediction, okay, of 80 of $99 here,
Mm.
which is the example that I gave you for. It actually doesn't predict a single number, but it is actually a probability distribution of your outputs.
Mm.
In the sense, so when you ask how much is this TV, how much TV is, it cannot be $100, but whatever. How much is your TV for? Okay, then your model will not say it is for $99 as per its prediction. Okay, it will dump a probability distribution for you of different prices that is possible, right? Now, suppose $99 has a probability of say 30%. Okay. Similarly, say you have like $500 a probability of say what do you say 10%,
Mm.
something like that. So you have a probability distribution of the different prices that are possible for that TV. Okay,
Okay.
and obviously the whole probability will sum up to one, right? Uh, so when a model outputs that distribution,
Mm.
now you have to pick one out of that distribution. Okay, one value out of the different predicted values from the model. How
Mm.
do you pick one value from that? Usually, you pick the one with the highest probability,
Mm.
right? If suppose when I say the model gave an out prediction of $99, it means that particular price of $99 has had the highest what do you say probability in the distribution which the model throughout,
Okay.
right? So you pick the one with the highest probability. Now there is one factor called as temperature, which we spoke about in I think in last few meetings.
Mm.
This temperature decides the randomness maybe of the model. Okay,
Mm.
suppose temperature has values from 0 to 2.
Mm.
Okay, and if the value of temperature is 0, that means the model will give you the one that has the highest probability, right? That is $99 here, for example. Okay,
Mm.
and temperature 0 means the model will be kind of predictive in the sense you will know that the model that the output prediction with the highest probability will be thrown out of the model output.
Mm.
Okay, so you will get that as the value. But if temperature increases, okay, then
Mm.
your randomness of the model increases. Okay, it
Mm.
will not necessarily pick the one with the it will not pick the one with the highest probability, but rather one with the lower probabilities. Okay,
Mm.
So it will juggle and pick up one from the lower probabilities values. Okay, so
Okay.
that is what temperature does on the model's output, right?
Mm.
So you input a query into the model. The query gets converted into tokens.
Mm.
The tokens converted into vectors,
Mm.
and then the model finds for the model tries to predict the next token based upon the uh, nearest vectors for that vector. Okay,
Mm.
which can be predicted. Suppose you will predict say 10 prices out of the model. Okay,
Mm.
so you will find 10 vectors which could be the next possible outputs from the model. Those vectors are outputted. Corresponding to those vectors, tokens are outputted, and then those tokens are sampled to give the natural language output. That is how the forward pass works. Okay, so it's actually a probability distribution is what I wanted to clarify here.
Okay.
That is the
Okay.
first step.
Mm.
Right. Now, the second step here is the loss calculation. Okay, so I mentioned about the $10 of absolute difference between the prices, right, in prediction and ground truth.
Mm.
So uh, that is not exactly what the model checks. Okay,
Mm.
in the sense, so when the model made predictions, right, of say suppose it predicted 10 prices with different probabilities, which adds up to one.
Mm.
Uh, Now the actual ground truth was your $89, right?
Mm.
Instead of instead of checking the $99 absolute difference, okay, the model actually checks that what is the probability that the model gave to $89, in the
Okay.
sense
Mm.
what is the probability the model gave to the ground truth.
Mm.
Okay, suppose you got zero point 0.3 as the probability for the $99. Okay,
Mm.
but the in loss calculation that 99 doesn't matter at all.
Mm.
Only thing matters is if the ground truth is $89, how much probability your model gave to $89. Okay,
Mm.
suppose model gave $89 a probability of 0.05, that is 5% only.
Mm.
Okay, then your model is behaving totally bad in
Mm.
that case. Okay, the one that is the ground truth, your model should give the highest probability to the ground truth. So that is the objective in the whole training.
Mm.
So if you realize the prediction actually doesn't matter, okay, for your instance, $99 of prediction doesn't matter much, okay. Here, what matters is the probability for your ground truth. That is what the loss is uh, calculated on.
Mm.
You got the point. This is the important point
Yeah,
over here,
yeah. So
right?
basically, its prediction and the ground truth can be different, right? I guess.
They can be different. They can be same. Yes, if that is the same, that means you have zero loss,
Huh.
no loss at all. That is a
Mm.
perfect model, okay,
Okay. Okay.
right? So when the model predicted $99 as the prediction,
Mm.
right? That prediction is not relevant in the loss calculation. Okay. The
Mm.
only thing that is relevant in the loss calculation is when the model threw out the probability distribution of different prices,
Mm.
then what is the probability it gave to your ground truth value of $89?
Mm.
Got it, right? So
Got it.
what we do in the loss calculation is we pick up that probability and
Mm.
we do a negative log of that probability.
Mm.
Okay, so that means, okay, so you know the log of one is zero,
Mm.
right? That
Mm.
means log of one. I told law in loss calculation we do a negative log of the probability, correct? Now,
Mm.
if the probability is suppose one, right? And the log of one is zero, or negative log of one is like zero. That means zero loss. That
Mm.
means if you give the probability of one or 100% to your $89,
Mm.
then the model is giving you accurate results. Okay,
Mm.
next following me till here,
Yeah.
right? And suppose if you get the prediction of 0.05 as the probability
Mm.
for $89, which is your ground truth, then log of a smaller number is the higher number.
Mm.
I
Correct.
mean, the negative log of a smaller number is a higher number,
Higher
no?
number. Yes.
So means your loss will become big. If your
Correct.
probability that you model gave to the ground truth is less, you'll get a
Mm.
big loss,
Mm.
right? You'll get a huge loss.
Yeah.
So that means that is simple math, okay? So that means if your model is predicting, when the model threw out the probability distribution of different prices, it can predict. And if it gave the less value to your ground truth, then
Mm.
in that case, your loss is huge,
Mm.
okay? And your whole point of fine tuning, your training is to minimize that loss. And if your model gives the high probability to your what you say, the actual ground truth in its probability distribution,
Mm.
then the loss correlation will be a smaller number, okay? And
Okay.
the whole point of view is to move from a higher loss to a lower loss, or from a lower probability of your ground truth to a higher probability of, okay?
Okay.
But it is, I think it is not practical to get zero loss or
Uh,
probability of one for the ground truth,
yeah,
because
yeah.
the model is only predicting one value, okay?
Yeah, yeah.
That is improbable. If that is happening, that is a wrong thing happening in the sense your model is overfitting.
Mm.
That is the thing which we want to avoid. I'll come to that. Okay.
Okay.
So you'll always have to move higher loss to a lower loss. So that is your loss calculation. Okay. That is the loss. It is what is it? Is it depth? Okay. I hope that is clear. If you have any questions, we can go over it.
We can get go forward, Vinod, yeah.
Okay. All right. Perfect.
We have another like
Then comes
five
your.
minutes, okay, for the call to end, I guess. 40 minutes, right?
Oh, okay. All right. Sure.
Yeah.
Okay. Then comes the next thing of back propagation or backward pass. In that, as I told, you have to calculate like which parameters you have to tweak to, by what magnitude, in what direction, so that your loss becomes minimal.
Mm.
Okay. And the step is called as backward pass or back propagation.
Mm.
Now, from what I have read, or what I have seen is, I'll just give a history, small history of online in that is, so earlier, before the, so back propagation is a method, okay? So before the back propagation method actually was being used,
Mm.
right? The loss calculation at this point of backward pass was very complex, okay?
Mm.
Was mathematically very complex. And I think the one paper came out on back propagation in 1970s or so. And in late 1980s or so, the famous guy, the godfather of AI,
Mm.
Jeffrey Hinton, Jeff Hinton. Okay, that guy actually used the back propagation to do the loss calculation. Okay, and after that, the loss calculation has become very comparatively simple.
Mm.
Okay, and that backward propagation is being used to do the backward pass calculation.
Mm.
Okay, the delta, what you call the gradient, is
Mm.
what we call is the gradient. Okay, the gradient is what we calculate for
Mm.
the parameters, right? And because of backward propagation, what you say, that paper, it has become now pretty simple. And we once we do that calculation using the backward propagation technique, I don't know about the details about how we calculate what is backward propagation paper and all. I have to go into those details yet, but yeah, we calculate the gradients in the backward pass step, right?
Okay.
And in optimization steps, we apply those gradients onto the parameters, okay? The
Mm.
delta on our parameters, okay? So
Mm.
that the loss comes down, okay?
Okay.
So that is the whole flow of your fine tuning,
Okay.
right? Now, forward pass is anyway pretty clear. There is nothing more to add there from my side, at least,
Mm.
okay? And the loss is also I explained in depth, which is like very important concept here, loss calculation.
Mm.
And then comes the backward pass is also I've done to the best I can. I only know that much, sorry.
Mm.
And optimization is also applying the gradients. It is okay. So when you use gradients to do the when you use the gradients to optimize your loss, okay, to decrease your loss, it is called as gradient based optimization, I guess. That is the term what they use in the industry, gradient based optimization. And that is okay. So this is like the whole fine tuning flow. Okay, now comes different parameters that we use in the model, okay, in the model training, okay, different training parameters
Hey,
we use.
Vinalon, hey, no, sorry to interrupt. Just one suggestion, okay? If you, when you're explaining, I think it's better you share and try to show something, draw or something, man.
Pawan, I think
Yeah, yeah,
Vinal is, I think, not in front of
Oh,
his
okay, okay.
laptop.
You're on.
Okay.
Okay. Sorry. Then carry on, man. Carry on.
So
yeah, I'm
Pawan, I
traveling.
think it's like just 1 minute remaining. Okay, can we like Pawan or somebody can maybe start a Zoom call so that we can connect that rather than getting disconnected from this call.
Yeah,
Yeah. Okay.
Can
Then
you
I'll
ping me the
start.
link? You start and just ping me the link. Okay, we can connect in
Yeah.
that Zoom session. Yeah. Thank you.
Okay. Thank you.